Hello everyone, my name is Mansaba Gohil and I want to share the knowledge on transformers and large language models. So, as part of my subject Advanced Machine Learning, I will be giving you a short tutorial of what the transformers and LLMs are. And if you want to apply them, then how can you apply them with the language Python? So basically, we'll go from introduction to the fundamentals of transformers. Then we will learn about the mathematical equations that are used. Then we'll learn the large language models and a bit of technical discussion. And then I will provide the Python code or the resources for the implementation purpose. So one thing that comes to our mind when we talk about transformers is exactly what is the definition of transformer. So to give you a brief introduction, transformers and large language models have changed the field of NLP, the natural language processing. The transformer architecture introduced in 2017 in a paper called Attention is All You Need. They used self attention mechanisms and positional encoding to process input sequences in parallel and making them highly efficient for natural language processes, computer vision, and multimodal tasks. So, you can see the example of transformers in nowadays application, for example, BERT, GPT, T5, or Vision Transformer, VIT. So, transformers are a type of deep learning architecture. The second thing that comes to our mind is what is LMM? Transformers are something that is has been heard about, and LMMs are follow into the same category, but there is fine line. There is a fine difference between both of these terms. LMMs are advanced transformer based models trained on massive data sets to understand and generate human like text. They will leverage self supervised learning and contain billions or even trillions of parameters. So, few of the examples for LMMs are GPT-3, Falcon, or Cloud. As I said earlier, that there is a fine difference between both of them. One of the difference is in scope. So, transformers are used in NLP, computer vision, and multimodal tasks, whereas LMMs are specialized in NLP processing only. We have also seen the difference in example and application that we saw. For example, BERT is a type of transformer, whereas LMM usually contain Falcon or GPT-3, a specific type. And difference comes in training data as well. Transformers contain various data sets, structures and unstructured, whereas LMMs contain massive text and corpora, trillions of words only. So another major difference is in the size of the model. Transformers can be small or large, so they vary, and LMMs are usually large. They contain around billion to trillions of parameters. And one thing that we one should notice is the customization. Transformers can be fine tuned for specific tasks, whereas in LLMs are fine tuned or prompt engineer for specific NLP task. So the next thing that comes to our mind is the fundamentals of transformers. What is the need that transformers are needed? The traditional NLP models, which have been in use for a few decades now, for example, RNN or LSTMs, which suffered from vanishing gradient problems and computational inefficiencies. So, transformers came into the picture and they addressed these challenges by introducing self attention mechanisms and enabling parallel processing and capturing long range dependencies. Second thing is the transformer architecture overview. So we can say that transformers can be mainly divided in six parts. So first part is the input embeddings, which is it converts words into vector representation. Second is the positional encoding, adds information about word order. third one is the self attention mechanism, which determines the relationship between words in the sequence. The fourth is the feed forward layers, which processes the attention outputs. The fifth one is the layer normalization and residual connection, which helps us in stabilizing the training process. And the last one, the output layer, it generates the final prediction. Now, once we know what is the general architecture of transformer, we should have a basic idea about the mathematical formulation and the equations that are used. Self attention mechanism is the one of the main mechanism which with given input tokens, the self attention mechanism computes attention scores as shown on screen. So one thing we usually consider is the compute query queue, key, and value matrices. The formula is as shown, but we need to take into consideration that X is the input and embedding, and WQ, WK, and WV are the learnable weight matrices, so they can be varied. The next formula is the compute attention scores using scale dot product attention. Again, is shown on the screen, where decay is the dimension of the key vectors. And the last formula, which is the computed the weighted sum of values, is used in self attention mechanism. The second thing which is usually considered is the multi head attention. Multi head attention allows the model to attend to different parts of the sequence simultaneously. So it concatenates head, different types of head, and as we can see in the screen, that WQ, where each head independently computes self attention. We also have feed forward network, which is in a way there is the every single transformer layer has a position wise feed forward network. And moving on to large language models, LMMs. As we discuss its definition, we have basic idea of what LMMs are. So, one thing that we need to take into consideration is how the evolution of LMM took place. First is the BERT, bidirectional encoder representation from transformers, which uses a bidirectional transformers for masked language modeling. The second that came into the picture was generative pre-trained transformer, which used decoder only architecture for text generation. Then T5, text to text transformer came into the picture, which treated all NLP tasks as a text to text transformation. And lastly, the one that is usually which is in the market and people like to discuss are the Falcon and Mistral, that is the efficient LLMs optimized for open source applications. So next thing that is taken is the training and fine tuning of LMMs. So as we can see, there are basically two portions: pre-training, where LMMs are pre-trained on large corpora using self-supervised learning, and fine tuning is done on custom data weights, which are used to specialize the model for specific task. Now that we know that what is LMM and what is the transformers, we need to know what kind of issues and what kind of things uh, that needs to be taken into consideration when we talk about their technical perspectives. So, and that first thing that we consider is the computational challenges. High memory requirements, LMMs require extensive computer power, then large data sets and models increase training time. So that's one issue there as well. And because distributed training and model parallelism are needed for large models, scalability is one of the issues that needs to be considered as well. The second thing is considered is how we can optimize these models. So we can use sparse attention mechanism, which helps us to reduce the computational overhead, and then quantization and pruning is also used, which reduces model size without significant performance loss. And last but not the least, which is the LoRa, low rank adaptation. It is efficient for fine tuning smaller devices, so it helps us in optimization where we don't need larger devices for high computation for low computational task. Now that we're clear on the architecture, computational powers, the technical terms, we might want to apply and use the transformer and LMM. So for that, I have given few resources. These are two links that I found which were very helpful and which are the basic knowledge. So I have attached them here. To conclude, I would say that transformers and LMMs have significantly advanced, specifically in NLP, enabling the state of art performance in text generation, classification, and understanding. So I think the future research should be focused on making these models more interpretable and efficient. These are the links that I used. Both links are present here. So I take advantage of this YouTube and articles which help me understand the concept more easily. If you want to look check them out, and yeah, that's it. Thank you for your time.